time, then this way all the time like that? Yeah. What happens at 0 though? What if I try and plug 0 in here? It's undefined, right? What if I plug 0 in here? It's still 1, right? There's a reason I'm showing you this. This is a major point I'm about to make. There is a difference between these two functions. This function is undefined at 0. So there is a hole here in this graph, right there at 0. But that should conflict with your brain a little bit, because you've been taught before that you could have in the very beginning said x over x is what? Just cancel them out, right? And this is what? 1, right? So if you do the algebra and turn that into a 1, then why would you have a 0? Why would you have a hole, right? Right? Like, what if I did that first and then drew it? Then I wouldn't have a hole, would I? Well, the reason why this is actually technically wrong is that when you were in college algebra, pre-cal even, anytime you cancel factors, anytime you've ever done that, there's an asterisk. You know how they always have like the little small print at the bottom of something, you know, the stuff you never read, right? Anytime you cancel factors that involve variables, like if you cancel numbers, 4 divided by 4, if I cancel that, that's 1. You don't have to worry about anything. But if I cancel things that have letters in them, X's, there's a little disclaimer here on the bottom that when you do this canceling, you're promising, I promise X won't be 0. See, you're saying to me, look, I'm going to cancel these, but there's a promise I'm making is that I'm never going to try and plug 0 in, because 0 would have caused a problem. I'll give you another example. Let's say that you had x minus 1 over x minus 1. Let's just say you had that. And you wanted to cancel those and turn them into 1. Can you do that algebraically? Yes. But there's a little thing down here. You say, but x can't be what in this case? 1. Because if x is 1, that gives you 0 on top and bottom, doesn't it? So anytime we cancel factors, we are automatically eliminating the possibility of ever plugging in a value that would have made that factor 0. You probably didn't talk about that in algebra too much, did you? Yeah? Does anyone remember ever having your teacher like tell you when you cancel factors you have to, yeah? You do? Good. That's good. I'm glad to hear that. So let's get back to the problem up here. Just remember, when you cancel factors, there's a disclaimer, right? So look at that problem. Can everyone read it? I'm trying to let x approach 1. What happens if I do direct substitution to the top? If you plug 1 in on top, what do you get? You get 0 on top, right? Let me bring that down a little bit so I can get to it. There we go. So if I try direct substitution, I get 0 on top, and on the bottom I get 0 as well. And do you remember when last class, I told you like the heart of calculus came from this problem of 0 over 0, right? And is there a way around it? Is there some way we can get around it? Here we are. We have our first limit where we're actually seeing that we're getting 0 divided by 0, which is a problem, right? This is an issue. Normally, we would just say this is undefined. But see, we're not letting x be 1, are we? We're letting x get close to 1. Get really close to 1 from both sides, and we're trying to see, is the function doing something? So whenever we see 0 over 0, whenever from here on out, anytime you take a limit and you see 0 over 0, I want you to think of this. I want you to think, this is bad, okay? This is bad. We're not happy, okay? And that now it's going to require some algebra, or it's going to require a trick, all right? This is it. Cal 1 is now like officially beginning, all right, in terms of limits. We are trying to figure out what this function does as we get close to 1, right? What we know is that we can't plug 1 in, because if we try and plug in 1, we get 0 over 0. So we can't do direct substitution. So this is a bad situation, and we're going to need algebra or some trick. Everyone, where's the sign in? Did it go around? Here we go. Last time I gave you handouts, didn't I? I gave you one that had those 4 boxes on it. Yeah, good. All right, see it? That page that I gave you is called the limit summary. And what it did, there's a lot of information on there, even though it looks like there's not. There's a lot in there. But look at the top left box. Does everyone have it? Yeah? Yes. The top left box. Do you see in the top left box 0 over 0? And do you see on the bottom what it says? What does it say? Let me see. I forget what it says. That's all right. Use what? Algebra or trick, right? Anytime we're taking a limit and we see 0 over 0, we're going to use some algebra or some sort of trick. But do you see next to 0 over 0 there's a bunch of other ones? All right, stay tuned. That's what the rest of the next few weeks are going to be about, is what happens when we see all these other weird things, all right? So we're just dealing with this right now, 0 over 0. We need to do some algebra or some trick. So here we go. Let's try and do some algebra. We know we can't plug 0 in right now, right? We cannot plug in 1, right? We cannot plug in 1 or there's a problem. So we look at this and we start thinking through our algebra Rolodex of ideas in algebra. And what is one of the main concepts, main skills you need in an algebra class? The ability to what? Factor. You have to be able to factor, right? And does anyone recognize something we can factor here? Difference of cubes. This is a difference of cubes, right? So we learned in algebra difference of squares, difference of cubes, sum of cubes. Those are formulas that we should have seen. Now they are on your formula sheets as well, the ones that I handed out. I think it's on the first page. There's algebra summary. Let me see. Yeah, it's on reference page 1. Factoring special polynomials, the third topic down on the left-hand side. There's a formula here that says x cubed minus y cubed equals x minus y, x squared plus xy plus y squared. Do y'all see that there? Yeah? That is the difference of cubes formula. So what we need to see here is that, we've got x cubed, right? And then that 1, we could look at that as being 1 cubed, right? And then just plug into this formula. So what would that numerator factor to be? I'm going to rewrite the problem right now. Limit x approaches 1. What would it be? So x minus, for us y is 1, isn't it? Y is 1. So x minus 1. And then we have x squared plus x times what? 1. X times 1 is x. And then plus, for us, 1 squared would be 1. All over. And then the bottom 1 minus x. Notice when I rewrote this, I started here, right? And then I rewrote it, but I factored the top. Notice I wrote the limit again. You see, because I still need to take the limit. I still need to figure out what happens when x goes to 1. Any questions? Difference of cubes. Does anyone see what I can do now? It's a little hidden, but it's there. Can you cancel these? Not yet, right? Not yet, because this is x minus 1, and this is 1 minus x. The difference between these two is that that's a positive x, this is negative x, that's a negative 1, that's a positive 1, right? So they're off by a sign, aren't they? So how can you fix that.
Multiply a negative through the top.
You could multiply the top and bottom by a -1. That's one approach. The other approach is to factor a -1 out of either this factor or this factor. I'm going to choose to factor a -1 out of this. But you can do -1 top and bottom. You have the exact same result. So I'm going to do this. I'm going to leave the numerator alone. Not going to touch it. Okay, on the denominator, I'm going to factor -1 out. Okay, if I take a -1 out of here, take -1 away from that, that's going to be -1, and then that's going to change to a positive x. Do y'all see? All I've done is rewritten the bottom so that if I multiply -1 back through, I get that, don't I? That's what I get? But by doing that, I'm going to go one more line. By doing that, I can rewrite the bottom as -1, and then these two, I can just switch the order. Instead of writing it -1 plus x, I can write it as x minus 1. Take a moment to, take a step back and just look at what we've done. Make sure you understand all these steps, right? Here, we tried plugging 1 in. We got 0 over 0. That's bad. We need to do some algebra. We need to do some sort of trick. We noticed that the numerator is a difference of cubes. We use a difference of cubes formula. We notice these two factors are almost the same. I'd like to cancel them if possible. They're almost the same, but I had to factor -1 out of the bottom in order to make these two factors now look exactly the same. We good? I'm going to cancel them now. But there's that little disclaimer, right? There's that little disclaimer that if I cancel these factors, I have to make a little promise to you, don't I? So here it comes. I'm going to cancel these factors, but here's my little asterisk on the bottom. I promise what? But x can't be what? What would make this factor zeros? X can't be 1, right? So if I do this canceling, x can't be 1. Am I okay with that? Yes, because I'm about to do a limit, aren't I? So I'm going to let x, am I going to let x be 1 or get close to 1? Get close to 1, and this just says I can't let x be 1. So as long as I don't let x ever actually be the number 1, I can let it get as close as I want. It could be 0.99999, it could be 1.00001. As long as it's not 1, this canceling was valid. And that allows me to go to the next and almost final line, which is limit x approaches 1. Okay, I've canceled the factor, so I have x squared plus x plus 1 on top. And on the bottom, remember we canceled, but we still had a -1 down there, didn't we? Yeah? Okay, now at this point, we are at it's almost like we have a new problem. It's like a new limit now. Try direct substitution now. Like if forget all that ever happened and just say I put that up on the board. Would you have a problem anymore? Do you have a problem plugging in 1? No, just direct substitute, right? And what would happen? Let's see, on top you'd get what? Plug 1 in, you get on top 3, and on the bottom -1. So you say 3 on top over -1, which is -3. Notice from this line to this line, notice the limit went away. I stopped writing the limit out front. Why? Because I actually let the x approach 1, and that took me to this. So the limit doesn't go away until you actually let x go to that number. So someone might be sitting there going, wait a minute, but you just told me you're not going to let x be 1, and then we just let x be 1, didn't we? Well, we're letting x get close to 1. What we're saying is that we're going to get close to -3. I'm not saying we're ever going to get to -3. I'm saying that we should be getting closer and closer and closer to -3. So I think the only way to really kind of like finalize this problem is to graph that function and see what happens near 1 to convince you of what we just did. So it was x cubed minus 1 over x minus 1, 1 minus x. Okay, there's the graph of this function. Let me zoom out some more. Weird. Okay, there's the graph of this function. And we were interested in what's happening at 1, right? Move this over here. So here's 1. Here's the graph. Let me move this up a little bit. Can y'all see that all right? If we go to 1 on the x-axis, come down, here's the graph. Now look, I'm gonna click on it. What's happening at 1? Undefined, right? We know that, it's undefined. So this is what I was telling you last class. The computer, for some reason, can't figure out how to draw this. Technically, there's a hole here, right? But it does have a limit, right? From the left, where's it headed? And from the right, where's it headed? -3. You see, we found that algebraically without a picture. But it required, what, difference of cubes? And a little bit of other algebraic manipulation over here. So this is where I tell my students that, and this is where you're probably warned in other classes, this is where your ability to do things algebraically is going to be put to the test. Can you factor? How's your algebraic manipulation, right? This is it. This is where I always say that calculus is algebra on steroids, okay? That's the part that gets students in Cal 1, the part that really hurts them is the algebra. Like the concepts, most students can understand what we're trying to achieve, but it's the algebra that they get hung up on. So my goal here for the next 45 minutes is to show you as many problems as I can to expose you to as many of the different types of algebra things that you can see as I possibly can. And each problem I do is going to be another little thing that now you're going to think about when you're doing a limit, like, hey, I remember he did something like this. Oh, that, you know, so I'm trying to just go through like the box of algebra tricks and like, oh, remember this? Let's do that, okay? That's what this is, next 45 minutes is going to be about. How are y'all feeling? What's wrong with you all? What's wrong? Y'all seem, are y'all depressed? What's going on? Y'all don't seem very enthusiastic. Are y'all worried? What's going on? You're fine, I'm just overreacting? What's happening? It's like my daughter always tells me, Dad, just chill out. I'm fine. Huh? You all right? All right, take a look at that one. What happens when x goes to 0? Okay, so you said undefined, that's true, but I want to know, like, in terms of when x goes to the top and the bottom, what we're getting. So, like, try and do direct substitution right now. Plug x into the top, what happens? You get 0 on top, don't you? Okay. And on the bottom, you get 0. And 0 over 0 is bad, right? When you're doing a limit, 0 over 0 is bad. That means we need some sort of algebra or some sort of trick, right? So the question is, what algebra and what trick is going to get us to that point where we can somehow cancel something? Let me say that again. The question is, what sort of algebra or what sort of trick is going to be required to get us to the point where we can cancel something and no longer have a problem, right? Because the problem we have now is 0 over 0. If we can cancel something, potentially we could get rid of that whole bad 0 over 0 happening. In the last problem, didn't we cancel that x minus 1, x minus 1? We canceled them, right? And that was the part that was giving me the 0 over 0. Do you see how if I plugged in 1 here, I get 0? Plug in 1, I get 0 here? Those were the two, like, bad apples in the bunch here. We need to get rid of those. So, well, I can tell you right now, you're not using difference of cubes because that's not a difference of cubes. You're not using a difference of squares because that's not a difference of squares. So what are you going to do, right? Yes?
Could you maybe separate
Like two different fractions?
And then kind of manipulate it.
You could, okay, so the answer to your question is yes, you can. Algebraically, it's completely legal because there's one term in the denominator and two terms up top. You could do this over x and that over x separately as two fractions. That's completely legal. However, it's not going to get us to where we need to go. But yes, that's okay. So look, this is a part of the class where, like I said just a moment ago, we can sit here and ponder this for quite some time and get people's ideas of what they might want to do. But unless somebody's actually done this before, you're probably going to be stuck, and which means you need to see me do it for that first time so that you kind of know now in your learning like what paths you might want to be entertaining each time you see these problems. All right? But I'll give you another 30 seconds to think about it.
Would you
Add one to where?
the top and bottom?
Add, when you say add one, you mean just like plus one here, plus? You can't do that. Now let's see why. Let's take the fraction 4/5, okay? Or let's do another fraction that's easier, 1/2. Are you allowed to just add one to the top and bottom? Why? If you added one on top, you get 2, and on the bottom you get 1/3, and that's not the same fraction. Now you can always multiply by 1 on top and bottom, but you can't add. All right, 30 seconds, no? You're going to multiply by the conjugate, exactly. Exactly. All right, so what is the conjugate? The conjugate of something is the same thing, but change the sign between them. So if you have two things being added together, the conjugate is those two things with a subtraction between them. And it works both ways. So if you have subtraction between two things, the conjugate is an addition sign between the two. So why you do this, you're just going to have to see like it works, okay? We are going to multiply the top and bottom by the conjugate of the numerator. Remember, I can always multiply a fraction by 1, can't I? Anything can be multiplied by 1. So I'm going to multiply this by 1. But the one that I'm going to use is not 1. I'm actually going to rewrite that as the conjugate of the top over the conjugate of the bottom. Conjugate of the top over itself. Do y'all see that the square root of x plus 1 is the conjugate of that? And that over itself is a 1. And that doesn't change the problem because anything times 1 is itself. Show of hands. How many of you think that is a very unnatural thing to just do? Thank you. That should not seem natural to you, right? I mean, like, you're sitting here, all of a sudden you come in with a conjugate. Like, why, right? Why are you doing this? Let's see what happens. All right, let's see what happens with a conjugate. I'm going to multiply out the top, and then on the bottom, this x is supposed to go through to both of these, right? That's what's supposed to happen. Okay, stand by, watch what I do here. Let's start multiplying out the top first. Notice I'm writing the limit again because I haven't actually let x go to 0 yet. When you multiply this root times that root, what happens? What's root x plus 1 times root x plus 1? What's root x plus 1 times itself? Well, that's the same as squaring it, right? And what happens when you square a square root? It goes away, so you just get x plus 1. That's your first term, right? Okay. Now, when you do this times this, square root of x plus 1 times 1 is itself, isn't it? So that gives me a square root of x plus 1. And then, when I do this one, what do I get? Negative 1 times square root of x plus 1. Negative square root of x plus 1. And then finally, negative 1 times 1 is negative 1. Now, I'll get back to that in a moment. On the bottom, I think you would normally like to pass that x through, right? It just seems like we did it on top, we should do it on the bottom, right? I'm not going to, Because remember, what I'm trying to get is something to cancel, right? So I don't have a problem. And the thing that's causing a problem is this x because it's a 0, right? When x is 0, that's a problem. So I'm going to leave that x out here by itself and just write the other piece down here like that. So I multiplied through the top, but I didn't multiply through the x on the bottom. What do you see on that conjugate? There's something actually pretty nice on that conjugate. What happens to those middle roots? They go away, right? This root and this root go away. That happens every single time on a conjugate. The middle terms cancel. Anytime you multiply something by its conjugate, the middle terms cancel. Every time you multiply something by its conjugate, the middle terms cancel. Every time you take something and multiply it by its conjugate, the middle terms cancel. Every time, right? So that's why we actually did the conjugate, because we knew that it would get rid of the root. It would eliminate that root. Because when I do this times itself, the here and here the root goes away, and then the middle terms won't have roots in them because they'll cancel each other out. All right, what else goes away? It just so happens we get something else that goes away here. Ones, right? All right, so here's where we are. Check this out. It's actually really nice. We're at the limit. X approaches 0. On top, all we have is x. And on the bottom, we have an x, and then we have in parentheses square root of x plus 1 plus 1. You can cancel them, the x's, can't you? With that little disclaimer, though, right? I can get rid of this and get rid of that. Now, when I get rid of it up here, what's still up here? There's still a 1. Don't forget there's a 1 up there. You can't just make it go away. But remember here, I'm making a little thing here. But x can't be 0 now, because if x is 0, I get 0 over 0. Yes?
Are we going to write that?
You don't need to.
Okay.
You don't need to write that for me. I just want you to keep reminding you that algebraically, you are kind of making a promise there. All right? I'm going to write one more line. Limit. I still have a limit. I have not let x go to 0 yet. I have 1 on the top. These x's cancel, so the only thing left on the bottom is square root of x plus 1 plus 1. Forgot to put 0 here. There you go. Finally, we are at a point where I'm ready to do direct substitution and see what happens when I let x go to 0. So if x goes to 0, let's see what we get. We get 1 over square root of 0 plus 1 plus 1. But that's just 1 over square root of 1 plus 1. I'm going very slow. 1 over 1 plus 1, that's 1/2. The answer is 1/2. So right now, if I go to Desmos and I graph this function and I see what's happening as we approach 0, what I should expect to see is the graph coming in both sides, and the y value should be really close to 1/2, right? That's what should be happening. And then at 0, it's undefined. That graph would have a hole in it, although Desmos won't show me the hole, there should be a hole, right? All right, I'm not going to go to Desmos. Next one. So up to this point, what algebra have we needed? Difference of cubes, and then we've needed to introduce the conjugate and multiply the top and bottom by conjugate. I'm just curious, what was your name, Miguel? Wait.
Jacob.
Jacob?
Yeah,
Last name started with an M.
Yeah.
Okay, that's what it was. Sorry. What made you say conjugate? Were you just?
I mean, I remember how it looks like there was like the opposite sign, so you just multiply by like the same thing with the opposite sign.
Okay, but you haven't seen calculus before, or you have?
No.
You haven't. So that was just like a let's go for it type thing. And that's, I mean, that's good. Okay, what about this one? First step, try to plug 2 in, right? We're trying to let x go to 2. Can y'all read that okay? What happens on top? What happens on bottom? So you get 1, I'll go ahead and write it out. You get 1/4 minus 1/4. And then here you get 2 minus 2, so you do get 0 over 0, right? This is bad. We're not happy. And we're going to do some algebra or some trick. Now here's what's going to happen on the first test. Somebody who doesn't understand what's going on, has not asked for help on homework, and has just given up is going to go to the test, and when they get to this, they're going to write that down. They're either going to say that's the answer, or they're going to tell me that it's undefined, and that's all they're going to do. And they're going to move on to the next, which shows me that there's like absolutely no idea of what's going on here, because the whole point is, the whole reason we're here now is for this. We're going after the 0 over 0, and this is like just the beginning of the problem for us. We now need to see, how do we attack it? How do we go after this limit? What algebra are we going to use, right? Well, what we're looking at here is what is called or referred to as a complex fraction. It's complex fraction because it's fractions within fractions, right? You've got fractions inside of a bigger fraction. It's a complicated fraction. It's a complex fraction, right? All right, the general rule of thumb, and this is not every single time, but the general rule of thumb is that when you have complex fractions, you should start by trying to get a common denominator and combine the two fractions up top together first. So you see these two fractions? Let's see if we can't put them together with a common denominator. Is there a question? Yes?
I was just going to say something like about the next step, but I'm just going to...
Okay, so keep going, or?
Squares.
It's not a difference.
I was just suggesting.
Well, you could look at this as a difference of squares, but it's not a very natural one. Like, I'm not sure most people are going to see that that's 1 over x squared minus 1/2 squared. Yeah? Yes, you see that or no? Is that what you're saying, difference of squares right there? You could do that. But I'm going to stick to the rule of thumb because it's going to be much easier than approaching it this way. So how do we combine these two together? If I want to put these two fractions